Part 2 is measuring correlations. So we use a scatter plot to represent a correlation, and this is a scatter plot here. And you can see we have an x-axis running horizontally, and we have a y-axis running vertically. And then we have a number of points that make up a pattern in the middle. Well, one variable is represented on the x-axis, and in this case, it's the number of minutes a doctor in an outpatient consultation spends with each patient. So how much time does each individual get with the doctor? And it looks like we have a range from 0 minutes up to 20 minutes. And then on the y-axis is outpatient satisfaction. So, and this is a Likert scale, 0 to 5. And so in this case, it seems that the researchers are predicting that the level of patient satisfaction will increase as time with doctor increases. And you can see how these points work out. Each point represents one patient. So for example, looking at this individual right here, this individual has a 5 in terms of spending 5 minutes with the doctor, and their satisfaction is very low at a 1. This individual up here had almost 20 minutes with the doctor, and their level of satisfaction is at 4. And so you can see here that how each of these points represents an individual. So on this slide, we have another example of a scatter plot. And in this case, it's the number of missed classes on the x-axis and exam score on the y-axis. And so we can see the first student here appears to have missed quite a few classes, and they have kind of a low exam score. This individual up here has a fairly low number of missed classes and a high exam score. And we can see here that this is a negative correlation, meaning the two variables vary in the opposite direction. And we can tell because the general trend of the points appears to go in a downward direction. So we interpret the magnitude of a linear correlational relationship using 2 dimensions. We measure the strength of the relationship by determining how far are the points from the line of best fit, and the direction of the relationship, does the line of best fit point upward or downward. And I really encourage you to watch this content on the whiteboard demonstration that will be forthcoming. I think you'll get a better idea of it with that. So first of all, direction, is it positive or negative? And remember, in correlation, positive never means good, negative never means bad. All it means is, do they walk together or do they walk in opposite directions? So the direction of the plot is indicated by whether the points and line of best fit goes in an upward or a downward direction when viewed from left to right. So if it's positive, it means the direction of the plot is upward to the right. So the points go in an upward direction, like this. And you can see here we have the line of best fit, and we have some points scattered around it. hours revising, and exam results, positive correlation. The more time you spend revising, the higher your exam score. And so this would be a positive correlation. A negative, and that would have a negative sign, means that the direction of the points is downward to the right, like this. The number of flu shots given and the number of people with flu. The more shots are given, the fewer people with flu, and vice versa. So that's a negative correlation. When more flu shots are given, the number of people with flu falls, or flu jabs tend to prevent flu. And again, we don't think of negative as bad or weak. We don't think of positive as good. It just means the direction that they're going. You can think of it as plus and minus. Is it going in a positive direction or in a negative direction? And the other dimension we measure is the strength, and we measure it on a scale from 0 to 1. So 1 is really strong, perfect in fact, and 0 is a zero correlation. There's not much going on. So the closer the number in the correlation coefficient is to 1, the stronger is the relationship. So here we have some examples. First, we'll start over here on the right. Here we have a strong positive relationship. It's positive because the points go in an upward direction. And it's strong because if you would draw a line in here, these points would be pretty darn tight to the line. And in the next illustration on the far right, we have a weak positive linear association, meaning that as the points go, it's positive because the points go in an upward direction, but they're kind of far from the line. So it looks like more of a weak relationship, probably a moderate relationship actually, I would say, but it's not as strong as the other one. The points are a lot farther away from the line. And you can see an example on the far left of a negative or inverse relationship. It's inverse because it goes in a downward direction, and it's probably fairly strong. The points are pretty close to this line. And so this little activity in the corner is what you'll be doing to guess the correlation coefficient, and you'll be trying this out and seeing how you can do. I can't do it in this kind of video, but you can do it on your own, and we'll be doing it in the whiteboard demonstration. So the Pearson R value is the name for the correlation coefficient, or the numbers that represent the strength and direction of that relationship. So here we have again some examples. Strong positive here going in an upward direction, strong negative, the points are very tight to the line. Here we have some moderate relationships. A moderate positive, points are trending upward and they're kind of close to the line, and a moderate negative. And then a weak positive and weak negative with the general trend going upward in the positive, downward in the negative, but the point's not very close to the line. So the direction, how do you tell what the Pearson correlation coefficient means? You first look at the direction, whether there's a minus sign or not. And if there's no sign, that means it's positive. And secondly, you look at the strength, a number from 0 to 1. So the sign just tells the direction and the number tells the strength. And so we would think of a value of 0.8 or a strength of 0.8, whether it's positive or negative, as being strong. So correlation coefficients in that range are considered strong. Moderate would be a correlation coefficient of 0.5 with that plus or minus. And weak would be about a 0.2. Sample size makes a difference. Larger sample sizes lead to higher correlation coefficients. And in fact, you really you wouldn't be encouraged to run a correlation with numbers less than 30. A perfect correlation is one in which each point is exactly on the line of best fit. That means that we can perfectly predict an individual's value on the y-axis if we know their score on the x-axis. And you can see here that this would be a perfect positive correlation. The Pearson R value would be 1, and it would mean that every point is just on the line, If we know what the value of x is, we know what the value of y is. This might be something like height in inches on the x-axis and height in centimeters on the y-axis. A perfect negative correlation is shown in the middle. We can see the downward trajectory, meaning it's negative, and it's perfect because every point is on the line, so this would be r equals -1. And this might be something like the number of weeks we have finished during the semester on the x-axis and the number remaining on the y-axis. If there are 16 weeks in the semester and we've completed 12, then we know that we have 4 left to go. If we know what x is, we know what y is. And you can see in this last example what a zero correlation might look like. They look kind of like a zero, in fact. The points are just all over the place and there's no detectable relationship. This is the game that we'll be playing to guess the correlation, and this will really help you with your understanding. So if you're doing this on your own, be sure to click on the link and try out this activity.